All right, and hello, everybody. So we have an extremely special episode of the podcast today. So it's not just going to be myself and Shashank talking about the news and AI, but we have an amazing guest. So this guy is honestly one of the smartest people that I have ever met. And I say that with like no exaggeration. He is just like a wealth of knowledge, and I'm incredibly grateful that he was able to come and join the podcast today. So Lonnie Chrisman, who is currently the CEO of Lumina Decisions. Oh, sorry, not the CEO, the CTO. My bad. The CTO of Lumina Decision Systems, and where they make Analytica, which is kind of their main product. So Lumina Decision Systems is the company, Analytica is the product. And he is making a new thing called Assista. So Lonnie Chrisman is an incredibly just smart and interesting guy. He actually was the #1 electrical engineering student in the United States when he was at Carnegie Mellon. And not only did he go... Oh, sorry, my bad, Berkeley. And then... sorry, Lonnie. So he did that at Berkeley, and then he moved over to get his PhD from Carnegie Mellon. And then later on, he now has been the CTO of Lumina Decision Systems for 21 years. We were actually just talking before the podcast, and he decided to work at Lumina Decision Systems and actually turned down working with Peter Norvig at his startup. So he is like really like a mover and shaker, and just like an awesome guy. And I'm really excited to talk with him today. And yeah, Lonnie, thanks so much for like taking the time to meet with us today.
Okay, well, thank you. That was a rather humbling intro. Wow. Okay.
Yeah. So one question just to kind of start it off is you're building the software you've been working on for 21 years called Analytica, and you just came up with this new thing called Assista. Like, why would somebody maybe want to use Analytica, and why would it be better than maybe something like Excel?
Yeah. So, so Analytica is a platform that is really designed to help people build decision models. And Excel is really not a very good tool for this. Excel's great for some things. I've actually heard that one study that Microsoft did in the 90s, they found that only 3% of people using Excel even knew there were cell formulas that were possible. So a lot of people use Excel for things other than quantitative modeling. And it's great for ledgers. But once things get really complex, it's very limiting. You're kind of stuck in 2 dimensions. There's no real structure to the model. It's not visual. People talk about big Excel models being completely impenetrable and very non-transparent, and they're very inflexible. You know, once you have to sort of commit to your basic structural assumptions, and once those are nailed down, you really can't change them. And the reality is, when you start building models, at the beginning, you're dealing with real-world situations that you're trying to model, and it's just a big, confusing mess. You don't know the right way to model it up front. Turns out a lot of those decisions are better made later in the process. So with Analytica, I should say, I've been kind of working, this is my area of research, I guess, for 21 years, is working on, how can we use computers to help people make tough decisions in situations where there's little or no historical precedent, and what types of tools can we bring to the computer, to the software, to help people think more clearly, to use model-based decision making, and to develop these things. And so, it's really been built for that purpose. And what you find is it's more scalable, it's transparent, it's more flexible, and a whole host of things. It's multidimensional. It models uncertainty explicitly. It was built for that from the beginning. And all these things are just much more powerful, much more appropriate when you are doing model-based decision making. Another question? Shall I? Okay.
I'm curious. So this seems like a very complex tool. What are some of your customers using this for? What are some examples or ways that this is benefiting people?
Yeah. So it's a very deep tool. It's been under development for a long time. It's very mature, but at the same time, it has a simplicity to it. So part of its design was made to help people learn how to take a real world problem and translate it into a formal model. That's a process that's kind of a skill that's hard to learn, hard to develop. And because it's very visual and stuff, it actually lets you do a lot of that stuff fairly easily. Its depth comes in useful because you don't kind of get stuck. As far as what people are using it for, it's a domain agnostic modeling environment. So it's appropriate across a whole host of domains. And we do have people in dozens and dozens of different domain areas who have used it and are using it. In fact, I think about 5 years ago or something, figured out that, we'd had over 2,000 organizations that have used Analytica, pretty much every name you can think of, and about 45,000 people at that point had worked with it. Our strongest uptake has been in the renewable energy sector. And we have a consulting arm at Lumina as well that does a lot of work in the renewable consulting, the renewable energy sector, and some of that's risk management in that sector as well. So, for example, if you are, either say California, the grid, or your utility companies here, and you're trying to figure out where should we put batteries on the grid, and what's the cost effectiveness of those? Well, this is a good tool. That's another one would be like, when should we build a new power plant and stuff like that? That kind of thing has to take a lot of stuff into account that's, again, sort of unprecedented compared to what happened in the past, because, what's going on here is the world's been changing, and, there's this uptake of solar panels and electric vehicles and wind, and there's changes in how people use energy and where they live. And, you're trying to make decisions that affect, the next 30 years and involve big capital investments. So model-based decision-making there, could allow you to really make all your assumptions explicit, to bring people onto the same page. So, we find advocacy positions often are a stumbling block when you have big decisions. Different people, kind of nail down their positions and they don't communicate well. But model-based decision-making will kind of bring people onto the same page and allow them to talk about the same assumptions. We've helped some, let's say, unnamed utility company deal with the decision of when they should cut power to avoid setting a town on fire from when the winds get too high, and how to use the finite resources they have to best maintain and upgrade their gas pipeline infrastructure so they don't accidentally blow up a neighborhood. And if some people in the Bay Area here may remember a big explosion in San Bruno 10 years ago or something, where part of the neighborhood was blown up from a gas pipeline exploding. So those are some examples in that sector. We've seen a lot of usage in the food risk safety area, USDA, FDA, and some other countries' equivalents. And I've not been very involved in that. I don't know too much about it, but that was big. There's people who do portfolio management in pharma. One of the leading tools, a company now called PlanView, used to be called Enrich, I think they were acquired, had a leading tool for pharma companies that help them manage their portfolio of drugs that are under research. And that was all built on top of Analytica. I've seen forestry. I've seen beluga whale management, setting hunting limits. I've seen water quality modeling, environmental modeling. There was a project they were thinking of sequestering all the nuclear waste from power plants in a mountain near Las Vegas many years ago, and they used Analytica to model that. Oak Ridge National Lab has a site that the government uses to figure out how veterans who have been exposed to radiation should be compensated, like what percentage of their cancer could be attributed to being exposed to testing of nuclear weapons and stuff. And they have big models that run in Analytica that compute, that probability and that determines what their payment will be. We've seen it in manufacturing, some in finance, not as much as people would think. It seems like a perfect tool for the financial domain.
I definitely would think that to be like a perfect tool for the financial domain.
Yeah.
So I guess
all over the place. Yeah. On the Analytica.com website, there's a case studies section, and it has a lot of really neat examples in there. I'll mention one other one real quick. This one has gotten a lot of attention, won several awards. There was a documentary made about it. But it's a neat example. So there are these big oil wells that are off the coast of Santa Barbara. And if you ever are in Santa Barbara or have been there and look off the coast, you'll see them out there. Everybody's familiar with them. And it turns out these oil wells were put there around 1970, and they are huge. They sit on these big platforms, and the largest ones are larger than the Empire State Building. They're sitting on the ocean floor. And when the oil companies first got the leases to put them there, they made an agreement with California that said when they run out, they will remove them and restore the floor of the ocean to its original pristine state. And, well, those oil wells are pretty much running out now, okay? So, but it turns out they are now the most bioproductive regions off the California coast. They are giant reefs. They're encrusted with corals, several feet thick. Small fish breed there. It's, a safe area for them. And the marine biologists certainly don't want to see them go away. Well, it turns out coming to an agreement for how to dismantle these has been an area of absolute contention. There's, we got involved with this, but there were, I think it was 23 different organizations that had interests in this. There were the oil companies, of course, in the state of California. There were legal defense funds that wanted to make sure the oil companies were held to their agreements. There were the fishing industry, the shipping industry, the environmental concerns, and marine biologists, and so on. And they went for years and years, just never getting anywhere. This is an example where you just have all these advocacy positions and people just talk across each other. They just don't speak the same language. And really, we came into this project and built a model where in Analytica, where we took everybody's concerns into account. We looked at all the different assumptions and modeled those explicitly, and we modeled all the different objectives people had explicitly, and the various parameters, that were in people's control, how to, what decisions could be made. And we shared this model with all the groups, and they were able to play with different decisions and see what the impacts were. And a lot of them learned about objectives they'd never thought about before. And I wouldn't say that they necessarily came to agreement on everything, but they did come to almost unanimous agreement on what the best solution should be. I think we had only two organizations that did not have the same opinion. And the solution was basically to remove all the piping, of course, and then cut cut these towers off 180 feet below the surface and topple the top part down to be a secondary reef on the floor, and leave the giant structure there as a giant reef. They drew up a plan where that would save the oil companies $500 million in decommissioning costs, and that $500 million of savings would be split between the oil companies and a new coastal defense fund to help with the ecology of the California coast, and with some provisions that if the oil companies didn't actually do the decommissioning, that their percentage would shift over. And this was a while ago. Governor Arnold Schwarzenegger signed new legislation into law to change the lease contract and adopt this solution as on his last day of governor, as one, which is it was an act that he's meant to draw attention to. So it's kind of a big deal. I notice those oil wells are still out there, so oil companies I think are dragging their feet. I don't actually know. I mean, but yeah, it's a really neat example. I think of it has a lot of similarities with things we see often, where you have a lot of different decision makers who just have advocacy positions, even within a single company and they're just not talking the same language, but once you start talking about a model, the conversation changes and people start talking about particular assumptions, and so that's why this model-based decision-making paradigm is so powerful. It's a generalization of data-based decision-making. You hear people say, or data decision-making, right? Data-based, I guess. So you hear people say, we're making our decisions based on data. But the fact is, that's not really a very good term in my opinion, because data is always about the past. And what you're always really doing is you're trying to make a decision about your situation in the future, which is always a little different from what your data came from. And so model-based decision-making is trying to take those differences into account. And
yeah, that makes a lot of sense. So first of all, that's a wild story about like the reefs off the coast. Or you said it's like the oil rigs off the coast of Santa Barbara.
Yes,
like, I feel like that'd be really interesting to maybe go scuba diving there if they allow it. Like I would.
Yeah, a lot of people scuba dive out there.
Really? Yeah, that's cool. Yeah, like snorkeling and scuba diving. That seems like fantastic, and also like it seems kind of like a win-win where like you get like all this great new like fish ecosystem, plus like the oil companies don't have to pay as much, so it's kind of nice. And then if hypothetically you could move those big rigs into the ocean, then you don't have to worry about like the kind of the quote unquote like ugly view. So that's pretty cool. But I wanted to kind of get into like how you sort of view thinking about these models, right? So like to me, like kind of simulating one of these complex scenarios that has a bunch of different focus groups and interest groups seems like a really kind of complicated thing. And I know that something like Analytica would help with that, but I still feel like there's probably a lot of like the skill required in making the model. Because, sure, like you have the tools, right? Like I have like the software that can help me, but like I feel like, it might be like challenging for me to kind of like go and figure out like, like what even are the variables? Like what is the problem that I'm trying to solve here? Like it seems like kind of hard. So like how do you sort of like, what if you're thinking about like a model, how do you start? Like how do you like figure out like what are like the important parts of like a model and whatnot?
Well, you're absolutely right on everything you just said. So, I mean, the situation that's pretty ubiquitous is that you have a really complex, real-world, messy situation that just, you might think, oh, I could really use a model, but boy, I don't even know where to start. This is really confusing. I have ideas of what factors I want to incorporate, but really no idea how to go about doing it. And so this is the normal state of things. This is what you always face. And actually, I'll mention right now that I am this is what my AI project is all about, is really helping lower the bar here. But even before that, the whole research on Analytica has been to address this exact question. So the general approach here is we actually always start by drawing an influence diagram and not of the whole problem, but really taking just one really small part of the whole problem.
So could we take a step out? What's an influence diagram for?
Yeah. And so an influence diagram is just a drawing that has nodes connected by arrows. And the nodes correspond to variables, and we distinguish different types of variables. So we always usually try to start with objectives and objective variables. An obvious objective is often profit if you're working with a business situation. But it might be, protecting sea life, off the coast, or making sure the oil companies pay their fair share, or, making sure shipping isn't affected. So there's all sorts of different objectives. And these are, often things you either want to maximize, minimize, or satisfy, right? So that's the type of node. We always kind of put those over on the right. And then decisions. So these are, asking what things are under our control. This might be, discrete decisions or categorical decisions. Do we turn the oil platforms into hotels, or do we get rid of them, or do we cut them off? They could have quantitative aspects to them. Often a decision will be how much of something we should do, how big to make this or something. We like to put those on the left, and now in between are a whole bunch of intermediate variables, and we try to basically connect these with arrows. And these influence diagrams also have chance variables in them. Those are uncertainties that have to be estimated, and we call those out distinctly as well. Those often take expert assessment. And so anyway, you connect these with arrows. The process of drawing an influence diagram is similar to what people will often experience if you get some people into the room and you say, how are we going to approach this? And you take out a whiteboard and a pen and you start drawing, different shapes and variables on there, and you try to figure out how you connect them. And if you can connect the decisions to the objectives through a bunch of other variables that all seem kind of like plausible steps, then you say, hey, I think we've captured something here that's kind of capturing the essence of stuff. The thing you always want to realize is a model is, this is a good time to say what a model is too. So a model is a simplification of a more complex reality. And in AI, we use the word model all the time with these, large language models and, vision models and stuff. And a lot of people in the AI space don't actually realize why we're calling them models. And the usage of that term in AI is often kind of equated with, say a piece of software or an architecture, which is more of a software solution. But, that's not why those are called models. They're called models because they are approximating a more complex reality. A large language model is actually trying to predict the structure of language. In that sense, it's modeling. It's predicting the probability of the next token that's going to appear, and so it's used then as a component. So, but if you kind of back up, a model, the more general use of the word model means you're trying to capture a more complex system with a simplified representation. A conceptual model is another example, right? If you're trying to understand something, you try to develop a conceptual model. And so the challenge that you talked about in terms of finding out what the different variables are is trying to figure out, how can we capture the core pieces of this problem without capturing everything, right? So, and we have to find what variables are going to make sense for that. And sometimes in certain areas, people have developed ways of talking about things. Economists have, certain supply and demand and various quantities that they talk about. So it kind of helps you say, hey, maybe, if you've never studied economics and you're trying to describe the economy, it probably would be pretty hard to come up with supply and demand and interest and and interest rates, and figure out all those pieces. But people who work in their own areas often have ways of talking about things that can help a lot. I would say that that part of it, drawing an influence diagram, the key there is to start really small. You start with just not the whole thing, just a little piece of it, and that makes it very manageable. And it's just a matter of drawing something, just like you do on a whiteboard. You just dragging nodes to a diagram and connecting with arrows. And we find actually that very non-technical people can participate in that process. You have people in the same room, some technical, some of them not, and you're doing that, and people, I don't think that's right, and stuff. It works quite well, it's very understandable. So in some ways it seems like such an easy thing, but in other ways I think it's the hardest part of modeling, is figuring that formulation out. And then once you have that, we then flesh it out by getting it to compute. And we do quantitative models, and that's because hard decisions almost always involve trade-offs. They're hard because you're trading off things. They're complex, but they involve trade-offs, and they involve uncertainty. And so to really weigh trade-offs, you have to go quantitative. So you try to predict, a number for profit. You don't try to predict profit or not profitable or not profitable. Right. So that allows you to kind of make trade-offs. And so you flesh it out, get it to compute, and now that you have something working and simple, now you can start refining it. And so models get very complex. Often they do, but the idea is start simple and then add in additional factors and stuff little by little. And you often change your mind. You think, okay, I'm going to add this, and maybe I can model it this way. And, you change your mind. Now maybe I'll change it this way. So a big part of Analytica has been making it very easy to just switch around and change your mind. There's also always dimensions to models. So the time dimension, of course, but you'll have, you might have like a number of oil wells, right? And you might have stakeholders, and you might have, you might have different concerns. You might have different categories of this. You might have different scenarios. All of these things are various dimensions. And that's a core part of how you structure your model as well. So Analytica has always been a multi-dimensional modeling environment. We had tensors way before tensors existed, but Analytica's intelligent arrays are way better. Way better. Every dimension in Analytica is explicit. And so Analytica can actually kind of take care of knowing when two dimensions of two different values are the same dimension. And so you don't have to figure out how to transpose things to fit them together. And it also makes it really, really flexible, where you can just add a dimension to a model and you don't have to adjust any of the definitions anywhere. And so it really means that one of the absolutely unique things about Analytica that doesn't exist in spreadsheets or programming languages is those core structural commitments that you have to make. You don't have to make them till late in the modeling process, which turns out to be when they're more natural. If you're using a spreadsheet, you need to figure out how to lay things out right up front. And once you've done that, you're stuck. That's how it's going to be. And of course, it's very hard to go beyond 2 dimensions. You go through all sorts of gyrations when you have 4 or 5 dimensions. In programming languages, again, you really kind of have to commit to what all your dimensionalities are and what data structures you're going to use. And you build everything on top of that. And if you need, decide, that wasn't really the right way to go, it's usually a major investment to make the changes, So that's one of the big things we focused on a lot with Analytica and its design as well, is that ability to kind of make these decisions when it's, when it tends to be the right time in that process of building models. So, yeah.
I'm curious, do you feel like there's ever like a sweet spot that you've seen for models? So you mentioned that the models can get incredibly complex, and we've seen, with large language models, no one person could probably ever begin to understand all the intricacies of the model. But I'm curious that if you've noticed that in that maybe like sometimes like a simpler is better, or like I don't know, like have you ever noticed that there's sometimes like diminishing returns with having like a more and more complex model, or do you feel like sometimes you seem to like, the more variables you add, it kind of the better? I don't know like what you've seen there.
No, that's an excellent question, and it is absolutely relevant all the time. So there actually have been studies on that have shown that, kind of as a broad generalization, simpler models actually do better than more detailed, fine-grained, models at predicting and improving decision-making. Now, in reality, there's a certain amount of complexity that you need to capture the essence of your decision problem. But once you go beyond that, it can actually be harmful. So it's not entirely intuitive, and I think it's a natural human nature to make models more complex than they need to be. So yeah, I see that all the time. And again, the best models capture things simple. E equal MC squared. It's like, wow, what an awesome model. It captures so much and so little. So yeah, there's absolutely that. There's also a question that kind of was in there too, which is there a sweet spot for when to use models at all? And that's also a really important question, because there are a lot of decisions that occur every day that you want to make like that. And the difference between, a really mediocre decision and the best decision is not that big. And so you don't want to, be wasting your time, spending a lot of time to make a better decision on those things. You probably want to just make the decision, and, time is probably more important, or agility is more important than making a good decision. But there are more serious decisions, where, there's this fundamental trade-off between how much effort do you put into making good decisions versus executing, and, big projects and companies face this all the time, where, management and stuff just jumps into executing. And in I'd say a whole lot of those situations, you find a little bit of higher quality of the decision translates to a real big difference in execution cost. So I've seen stuff when people have looked at this that say there's the natural human tendency there is to execute too soon. People, maybe they don't know how to go about making better decisions, or they don't know what to do to improve their decisions. And so they jump into it too soon, and then they really pay the cost with execution, which a lot of times things could have been saved. The shuttle disaster report is an example where that was a big criticism. Why, when we lost the Space Shuttle Challenger, they said that had happened. So
I'm curious. Do you maybe have like a mental model on when it's worthwhile to make like a model? So for reference, like I work at Amazon, and one thing that we talk a lot about is one-way door versus two-way door decisions. So basically, a one-way door decision would be like a decision that like you can't take back. So for example, if I said like, oh, like I want to, I don't know, amputate my arm, well, that'd be like a one-way door decision. It's not going to like easily grow back, right? So it's like I'd probably want to do some modeling there to see if that was like the right decision, right? But a two-way door decision would be one that you could like easily reverse, or like maybe is like inconsequential, right? So it's like, oh, like I'm going to try this thing for dinner. Like I don't necessarily need to do a model of like the pros and cons of like, having Mexican or Chinese food tonight. Like it doesn't matter, right? Like I can eat another meal later. And if I didn't like this meal, I can try something else, right? So like, I don't know, like is there like any kind of like heuristic that you use to figure out like when you actually would go through like the trouble of like, actually like figured out your variables, trying to like, spend the time with like the decision-making process?
Yeah. I mean, I like that. I like all that one-way, two-way door stuff too. That's really neat. A neat characterization. I have to say I don't. I think that is such a broad kind of a broad area that I find it. I guess I'm hard pressed to come up with really simple heuristics. I think there's a lot of guidelines or principles. Things like you said, if it's a one-way door, that's probably important. That might be a good indication that it's worth the time. You probably have some internal feeling a lot of times as to how much difference could a good decision make, and you got to kind of probably want to make that up front. And and there are intermediate steps too. There is the potential for just sketching out a really simple model. Sometimes these are 10 minutes of work, and and then that might indicate it's worth a little bit more, and so on. My boss made a model for real use of when he should leave the house to go to the airport. The basic question there is there's a cost for sitting around the airport doing nothing, and the cost of leaving too late is you miss your flight, and then you gotta maybe you'll sit around even more and wait for the next one. But there's all these uncertainties in between. So, he actually made a model, so he could kind of pick the optimal time to leave the airport. And
that seems like a very valuable model for most slackers.
It does. What time do you go to the airport typically?
Maybe what was the conclusion from your...
Well, the model actually lets you put in a couple parameters like, what's your uncertainty distribution on how long it'll take you to get to the airport, and what's your cost, and stuff. So, that would differ depending on where you live and stuff like that. So, so you put those in there, and then what you get out is you can get out the optimal time to leave the airport, basically, and you can get out a curve that says, here's your utility distribution, at each time. And, what you find is your utility kind of goes up for a while as you postpone leaving. And then there's a certain point where it drops off real rapidly, because your probability of missing the plane goes up. And then it kind of starts going up again because, at that point, you might as well show up a little bit later because you missed your flight, As far as when I leave for the airport, I have to admit I don't necessarily do that, but I live pretty darn close to the airport, so it takes me 15 minutes to get to the airport. So it's not quite as hard. I use, I guess for me it's typically an hour in advance. The main uncertainty in my case is getting through security.
Yeah, that's true. Getting through security and whatnot. I tend to be the type of guy who will try to get there 2 hours in advance, and I would just end up spending an hour or so just twiddling my thumbs waiting around. It always seems like the wrong decision, but then I've had it happen in the past where I actually have missed a flight. So I remember that this one time I was driving. It was a 4-hour drive. I was driving back home. I was living in Colorado at the time. We were driving in Nevada. We just did a little Grand Canyon trip, and we got in this crazy traffic jam, and I missed my flight by 2 hours. And ever since then, I was always tried to add more buffer in. So I don't know. I don't think it's always the optimal decision. I feel I'm guessing that Shashank, you probably leave at the last minute for the airport.
I do. I hate the opportunity cost of just waiting at the airport and try to maximize the amount of time that I can get out of my day. But maybe thinking of some more consequential decisions that have wide-reaching impact. I was thinking more about the case studies that you mentioned. And it seems like maybe a lot of the decisions that are being made at large scales, at enterprise software, enterprise companies, at governments are maybe using tools like Analytica to make decisions. And this reminds me of my cousin who's working in Australia for the government to allocate resources for clean energy spending. And this is a very challenging task because you're at the whims of the current political government, which has their own agenda, and that keeps changing every few years. But these people working in clean energy, allocation of resources, and figuring out what is the best thing to work on, manage all these competing needs, agendas. That seems like the perfect use case. And she got an award recently And the award was because she proved that a lot of the initiatives that they had were completely ineffective or very bad and did not meet the promises that they had initially. So looking at some of the offerings at Analytica, it seems like you are helping people articulate the problem, clarify some of the assumptions, hidden biases that people may have, get alignment on multiple interested parties, and maybe make simulations about, okay, how is this model going to play out in different scenarios with various assumptions. And then maybe going to the next project that you're working on. How do you use AI to simplify this process and maybe help people clarify their assumptions in the first place?
Yes. And these are the things today I find very fun because, of course, with my AI background, machine learning background, I love working on this stuff.
And I kind of do this on a personal level with just a separate chat window in ChatGPT. Give it context, have it summarize my brain dump, and articulate the things that I'm thinking.
Yeah, and which is great. So so I mentioned I'm working on Assista, which is an AI assistant for Analytica, which is there to help the Analytica user in every aspect. And so, my long-term scope is really large. Help people use Analytica itself as the software if they have questions. What are the instructions for doing this, or just to have it do it for them. It's very agentic that way. Can actually, take actions within Analytica, and help them navigate the extensive documentation and find stuff there. And also to help people structure a problem, when they're, built the influence diagram and figure out what variables to use and all that stuff. And I think this is very exciting. So when GPT-3 came out, I thought, okay, maybe we could start incorporating this and using this. And I looked into it at that point, and then I concluded, no, it's nowhere close to being able to do this. But when GPT-4 came out, the whole landscape changed. I even remember the date still. It was March 14th, 2023. It was like my worldview changed because that just shocked me. And one of the capabilities that GPT-4 had was it seemed to have a really uncannily good capability of figuring out how to take a description of a real-world messy problem and distill the essence of it in the form of variables. And so I call this creative formulation. It's that creative act of how do you formulate your model. And since humans find this really challenging, it seemed like, wow, what an interesting synergy. A little more experimentation, I found that it was really low on technical proficiency, which, would be like fleshing out the quantitative aspects of the model, the expressions and stuff. And people catch on to that pretty quick and don't find that too hard to learn. But so it's like, wait, here's something humans are pretty good at and it's not very good at. So it's interesting synergy. So at that point, I launched this Assista project. I thought, okay, there's a real potential here to help, people with this step. And that could really make it, people who have that skill might not need as much help there. But I have that skill and I still use GPT for this stuff all the time. So it's, it's very useful. But, for people who aren't as good at that skill, boy, having an assistant there just seems really useful. We actually did a webinar, I think in May of 2023, live on Zoom, where I asked GPT, come up with an idea of a problem that I could build a model for right now, and something that is out of my area of expertise, and I said, well, how about managing wildfires in a natural wilderness? And I said, okay. I said, now let's, how would we structure this model? And I built a model for this live in a domain that I didn't even know going into the demo what the model would be of, and I didn't even know anything about it. So it's like GPT was really good at that. So Assista, I'm building on that capability. Assista has some areas where, it's, I think, quite a bit better and, does quite a bit more and is quite a bit more reliable than using ChatGPT. I have a lot of stuff going on in the background, which is, given a podcast like this, we can talk about a lot of the techniques and stuff if you're interested in it.
We'd love to go into the detail on that.
Yeah. I'll just say, first of all, this is a really interesting area to work on, is to really get it to improve. So it's, right now it's I call it an AI assistant. It's not just an, AI chatbot or something. It's, it actually can look at your model, look at what you've done so far. And it can change stuff. It can actually do stuff, for you. And it can build, starting to be able to build influence diagrams and so on. And right now is a really good time for me to put a plug in for a presentation on this exact topic that I'm doing on October 10th online. So it's at the Risk Awareness Week 2024 online conference. And I think you guys can put a link probably in the podcast notes.
Yeah, we definitely will. We'll put it in the description.
Yeah.
It's 2024. I don't know what year you'll be listening to the podcast. So but yeah, we'll put it there. So if you want to, is it in person? Is it going to be?
It's an online.
Okay.
It's an online presentation, online conference, and the link that I will give you guys takes you to a sign-up page, and the conference allows people to attend 3 talks without having to pay anything for attendance. So, assuming mine's the talk you want to attend, then you should be able to attend it for free, and see if you.
So I would say that I think it's definitely worth watching. We got to see a little sneak preview of the talk. We can't share it, but I will tell you that the talk is quite interesting. So if you have the time, I definitely would recommend watching the talk. I learned a lot. I learned a lot about Analytica, and we're talking now. Sometimes it's a little bit hard to visualize. Obviously everything we're saying, right? But Lonnie uses a lot of visuals. You can see him create like a model for a lithium mine, and it's something that I knew nothing about, but kind of seeing him walk through the process, really kind of made it so that I sort of could understand what he's talking about now. So right now we're kind of talking the abstract, but doing this and seeing it visually, it really kind of made everything sort of click. So I highly recommend watching this presentation.
Yeah. I kind of wanted to take a step back and maybe talk about what brought you here. What are the decisions and actions that you took that ended you as the CTO of Lumina Decision Systems? And maybe we can start with your undergrad years.
Okay.
And being awarded the best electrical engineer at Berkeley in the country.
That was clearly the pinnacle of awards for me. I got awarded the Alton B. Zerby Award as the most outstanding electrical engineering student in the United States of America, which is really quite amazing. And maybe I'll step a little earlier than that to tell you how I got to that. So I grew up in Silicon Valley, in Santa Clara initially, and eventually my family moved to Los Altos. And my dad had just graduated as an electrical engineer when we came here, and when I was almost 7. And he was, the smartest electrical engineer that I think I've ever encountered. He just amazing, capability I never came close to matching in electrical engineering, and very enthusiastic about the cutting edge stuff that's going on here. And so I was out one day playing cops and robbers with my friends on bicycles, and finding I was having a hard time keeping up chasing somebody when I was making the noise of a siren. So I came in and I asked my dad, I was, I don't know, 7 or 8, asked him, can I get a siren for my bike? And he said, he kind of looked for a minute and said, yes. And he reaches over and pulls out a piece of vellum paper, puts it on his desk, and starts drawing this weird-looking schematic. I'm kind of thinking to myself, what in the heck is he doing? I watch him draw this schematic, and he hands it to me, and he says, here's your siren. I thought, and anyway, he took me over to the workbench and proceeded to show me how to solder and read resistors and wires and how to read the schematic. And so I built that little siren, and we went into his work and the metal shop at his company and folded up a little metal chassis for it. And suffice it to say, the process of building it was a whole lot more rewarding and fun than the siren itself was. And I was hooked. So from then on, I went to my dad and would say, could you design me a schematic for this? Now I knew how to build stuff. So I got into electronics like that. I am, building all these projects. We built a Pong game about a year before Atari came out with its first home console, a whole bunch of stuff. And then, as I was getting into about the 7th grade, about 1977-ish maybe, another thing that he'd do is he was working on the weekends a lot, and he would take me into the company, and to kind of babysit me, he'd set me up on one of these little, they called them calculators at the time. They were little computers. The HP 9825 was the first one. It had just a line of LED display, 20 characters across, a little tiny printer, and a plotter hooked up to it. And I would sit there and I learned to program. So I was about 8 or something. And I became actually better than him at programming. So he was much better than me at designing circuits, but I got really good at programming. And so we both kind of got interested in building our own computer. We'd also go down to this little place called the Byte Shop a lot that was not too far from our house. And they had all these little Altairs and different things and kind of dream about these, And so we decided, let's figure out what computer we want to get. So we ended up deciding to join a homebrew computer club. It's called the South Bay Homebrew Computer Club. And there were actually 2 homebrew computer clubs in the area. There was one that met at Stanford. We went there for one meeting. And then there was one that met down near Aladdin. And they were a little bit different. The one at Stanford had speakers, and they were kind of in an auditorium. And the one in Aladdin was a lot more like our generative AI meetup group, I would say. We kind of sat around with a small group and talked about building computers and homebrew computers. And that one actually got started building a project together. And the same thing. So everybody built the same digital group kit for that. And then people in the club would design peripherals and share the schematics. And my dad was into the extensibility of that. He loved designing the extensions to it and stuff. And so when I was 7th grade there, I built, of course I did all the building. I soldered everything together. But he did all the designing. Built the first, my first computer. And that computer, I tell you, we put so many things on that computer. It grew and grew. It was really amazing. It was quite a monster by the time it finished its lifespan.
What were some of the specs of that computer? Do you remember?
Well, the very first version I built had 2 kilobytes of RAM. We had a tape recorder, a 100 baud tape recorder that we could store stuff on. And everything you did, was with a little hex interface to the memory. So go in there and you could change the hex values of each byte in memory and then go back and run it. And it actually had a little thing that showed you what the registers were, and stuff when you were stopped. Interestingly, I got that thing running, and I was playing with that. And one day, I got it to print the letter A on the screen, through programming in hex and stuff. And I have to tell you that was a moment when everything snapped into place. It was like, I get it. I know how this works now, And from there, I was able to program in hex and do all sorts of stuff. We upgraded that to 8 kilobytes of RAM shortly after building it initially. And then I think it was 24 kilobytes of RAM. These things were in pretty fast succession. These were things people, we were working on this group and stuff too. And then we did the big project, which was a 64 kilobyte memory system, which was maxed it out. It was a Z80 processor, which, if you know the 8080 processor, is more or less the same thing. And as soon as I'd say I never ever ran out of memory until I had 64K. And at that moment, I never had enough memory from then on. So from then on, it was like constant overlay swapping and everything,
Yeah, for reference, my MacBook right now has 16 gigs of RAM, which is like roughly like 10 million times more RAM than the first computer that you built.
Yeah, actually, isn't it 5 million?
8 million, but like, I'm rounding up a little bit.
Yeah. Oh, I thought you said 10 million. Yeah, you're right. Okay. Yeah. So, yeah. So, it was interesting. I wrote a Scrabble playing game completely in hex. I had 64 kilobytes at that time. If I needed space for the English dictionary. So I set aside, I had to plan out the whole memory kind of manually up front. I set aside 256 bytes for my code. Maybe it was 512 bytes, but which included both the Scrabble playing part of it and the dictionary editor, so that I would have all the rest of the memory for the dictionary. So I implemented a Scrabble playing game with a dictionary editor that took 512 bytes of code.
Wow, 512 bytes. That is wild.
And because I was self-taught, I didn't know better. I figured out on my own that the way you make decisions, if-thens or whatever, the way you have the code make decisions, is it would rewrite the code right in front of what it was about to execute. So it was self-modifying. So when you wanted to do something, the code would actually rewrite the code right in front of what it was, and then execute that code and rewrite it right in front of it. And so it turned out I got really compact code. But later on, when I started working with some professional programmers, they were like, that was not a good idea. And, I learned a lot. But so, yeah, those are the old days. They're really, really interesting.
I think that's a pretty good technique for code golf. In case you're just trying to get it like as compact as possible. It's like, why do we have this if-then? Just rewrite it.
Yeah. And, one interesting thing was at this time when we were building our computer, we went down to Byte Shop quite a bit. And one day they got in this new computer, and I really loved it. It had 2 joysticks on it, and it had color graphics. It was like, holy crap, it had a bricks game on it, and I was like, oh man, I could write so many games with this. I didn't like playing video games that much, but I liked writing them, And we almost got one, but my dad really was much more into being able to design and extend the system, and that one was a very closed system. I read later that those were the very first Apple IIs that Steve Jobs and Steve Wozniak built, and they put their very first ones there in the Byte Shop. So I was actually playing with the very first ones.
Wow.
And almost bought one, but
that would have been good. Aren't those worth like $1 million?
I don't know about that much, but I think they are worth a lot.
Yeah, worth a lot. Yeah.
Yeah.
So Steve Jobs and Steve Wozniak were hacking away at their Apple I and subsequently Apple II while you were also tinkering with your computer.
Yeah.
At one of the other homebrew clubs at Stanford.
Yeah. Yeah.
Yeah. How do you feel about where we're at now with ChatGPT and these LLMs, agentic behavior, and like the late 70s, early 80s?
Oh, that's a good question. So Yeah. So when I was in that stage, people would ask, I tell people I was working on a computer. I tell adults that, and they'd say, "What's a computer?" and and sometimes they'd say, "Is that one of those things in the basement of a bank?" And I'd kind of explain what it was. And I say, "In 10 years, you're going to have one. Everybody's going to have one." They look at me really strange and say, "Why would I want one of those?"
Yeah.
And I said, and I came up with some things they'd use it for and stuff, but a lot of them are true, but they're hardly hit the main things that turned out to be big. But I was off by 10 years. It took about 20 years for that to happen. In 20 years, everybody had one, and stuff. But I had zero doubt in my mind at that time that this was going to change the world. I was working on this funny little technology that, people around me, some people in my area in Silicon Valley here were very excited about, but nobody else knew what it was. I was just positive it was going to massively change the world. And I have to say, I have that same feeling now with generative AI and, with these AI technologies. And in some ways, I actually feel like the transformation from AI will be bigger than that one was. I think it will be a much bigger deal. There is a, Amdahl's law, which says, we tend to overestimate short-term change and underestimate long-term change. And I think that really, really applies to the current moment as well. So, it's very easy to look at this stuff and say, man, in 2 years, the world's going to be completely different. I can feel pretty confident that those estimations are off. And but when you say in 10 years or 20 years, this stuff will completely transform the world in ways that are beyond what we are imagining. That one I think is going to be very true too. So it's going to be very, it is going to be very, very big. There's just so many bottlenecks is what happens. There's so many bottlenecks to get something to where it transforms the world that, the thing right now that looks like the big bottleneck, it might solve, but it'll just kind of shift it to the next bottleneck, and some of these are technological bottlenecks. Some of them are, societal or economic or, whatever, but there's a lot of those you have to get through. And that's why things don't change as fast in the short term, but it's building a foundation for something really, really, really monumentally transformative, I think.
So what do you feel like some of the bottlenecks are now before we can kind of get to let's say, I don't know, like maybe like AGI, or like the singularity. I don't know if like we'd consider like AGI and the singularity, but I feel like they're kind of like similar, but like, what would you consider, kind of like some of those bottlenecks before we get to some sort of state where, maybe like computers are kind of better than humans at everything?
Yeah. So I'm optimistic we'll get there. And I'm optimistic it'll be in my lifetime. But and I'm a lot older than you are. But I have to say, I have to kind of temper this because I talk to people, they have kind of both sides, where I feel like they're way underestimating, and talk to people I think they're way overestimating how fast we'll get there. And so I think within the group I'm sitting with right now, I think it's going to take a little bit longer than I think you guys might estimate. And a big part of that question though is getting at, what we have in mind when we say AGI. And I think we all agree that it's something that has a similar level of capability to human beings. Now, we might not necessarily even care ultimately about having the same capabilities as a human being because we want to somehow make things better. That doesn't necessarily mean replacing us verbatim, but we have to somehow figure out, what we mean when we say that. And I think it's really easy to look at certain things that we really revere today and a lot of those are, high level capabilities like programming and things like this that, boy, it feels like if we do that, we've really conquered something. And this is a pattern I've seen, the whole 37 years I've been in AI is, people have always looked at some of these revered cognitive areas and thought that's what it means to solve AI. And, there's this guy, Hans Moravec at CMU back in 1990 that said, no, that's wrong. These kind of things are much, much easier than the things 2-year-olds do. And, the basic ability to live in the world and interact with the world and perceive and change things and deal in a 3-dimensional continuous environment and, really get causality right and all that stuff, trumps, stuff you do in natural language, and it will take a lot longer to get there. And it seems to be panning out, So, I think there's a long ways to go. I use the example a lot of times. I think a plumber is the epitome of, maybe one of the last. If we can get to the area, the level of a plumber, what a plumber does, then I'll say, okay, we're there. But we are so far from that. Plumbers they go into a situation where something's backed up, and they have to deal with a completely novel situation, geometric situation, etc. With who knows, weird plumbing that's been configured in a weird way with some completely, you have to figure out some weird clog or whatever's going on, or sometimes they have to dig through concrete, go through walls, repair sheetrock, sometimes carpentry, sometimes electrical stuff. They just have such a wide variety of things they have to adapt to, and then they have to figure out, how in the hell am I going to turn that wrench, in this tight area, It's like, you just got all these things like that are just so far beyond, where we're at. So in that sense, there's, I see a really long path in front of us to get to, quote, AGI, as I see what AGI means. But that doesn't mean that, the rate of progress that we've seen in the last, 4 years or whatever is mind-boggling, and it doesn't seem to be slowing down. So I think we're going to get, huge value out of this in all sorts of ways.
Yeah.
Even though we don't necessarily make it to this, quote, AGI, complete AGI. We're just, for a lot of people, the goalpost is just going to keep moving. Maybe my goalpost is out there a ways, compared to a lot of people. But I think you'll see just a lot of people keep moving the goalpost because,
Yeah, for sure.
Actually, I was going to say that having recently done plumbing at Mark's place with the help of Mark's landlord, I realize how challenging and complex it is, because each builder can have their own unique nuance and go off script of what is standard. And it requires a lot of critical thinking to solve these kinds of ambiguous, nebulous problems. But, one really cool thing that was announced recently by OpenAI was the O1 model, which is shown to have some kind of at least mathematical quantitative reasoning ability. And I don't know how novel of a model it actually is, as opposed to just incorporating a lot of the agentic behavior, chain of thought reasoning, React frameworks to reason out a problem with multiple steps. But what do you think about that? Do you think that's pushing the boundary a little bit and getting us closer to that reasoning ability?
Yeah, and funny you said that. I was playing with that this morning.
Yeah.
I was actually testing it out and seeing what it could do. Yeah, absolutely. I think what the O1 model is really focused on is how can we use inference time reasoning to improve the responses. So instead of just pumping through the language model and, spitting it out, how can we actually think longer and think in a variable amount of time? So if it's a harder problem, we should think about it longer. And that's a really hot area of research right now. There's quite a few things going on in that area, and I think that's one of several really important areas, and it's one that's certainly I'm very interested in. I've been following closely. Some of the other ones, of course, are multimodal domains, which gets a little bit closer to being in the real world. I think maybe actually, I'll say robotics, bringing these things into robotics to have more general robotics control and stuff. I don't know, the fielders in there, I'm probably forgetting right at the moment, but yeah, very hot area. So have you played with O1 very much yet?
Oh, we did briefly when we were at recording our previous podcast episode. I asked some basic questions, the strawberry problem. Yeah. It was able to solve it. Some of the YouTubers who tried it said it failed, but looking at their screen recording, it seemed like the times that it failed, it wasn't using the chain of thought. The times that it passed, it was using a chain of thought, and it was doing multiple steps of computation behind the scenes and then consolidating all those intermediate steps into a final result.
Yeah.
It seems like that might be a good candidate for Analytica too, to help you use a model that understands data as opposed to just predicting the next token.
Yeah. Actually, I don't know if it's really a very accurate thing to say necessarily it understands data, but I think it's it is the reasoning step, breaking out the compositional reasoning stuff.
It can reason about data logically as opposed to going with autocomplete, which is what it seems to be doing today.
Yeah. I guess one thing is if you had like a huge table, say, of numbers and things like this, that gets a little overwhelming for language models. And I don't know that the stuff in O1 solves that particular problem.
I would assume it would probably run a SQL query and do some analysis on the data as opposed to looking at the raw data by itself.
Yeah, I think so too. So that's true. Kind of code interpreter style. Yeah. So, I the very first problem I tried on it was in the same vein as the strawberry problem. And it didn't do as good. It was write a limerick that describes how many words are in the limerick, and I had 30 words. This limerick does comprise blah blah blah, and it had 34 words. Oh, no. And I said, did it pass? And I said, no, it has 34 words. It actually did that. It didn't actually redo it. I said, well, could you redo it to pass? And so that came out. This lyric has 28 words. Da 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 da. And it's like, no, it has 36 words. So it didn't do too good on that one for me. But I did a lot of advanced math stuff on it today, and it was a very interesting experience. Overall pretty impressed. But there were definitely a lot of limits. And Assista is doing some stuff that's kind of in this vein as well. And maybe I wanted to do all that stuff inside Assista, with O1, or maybe I can improve on it, on whatever's there too. You never know.
How does Assista do with large tabular data? Because you mentioned that a lot of these large language models have a hard time dealing with lots of data. Like if I have an Excel spreadsheet, it's not the best at interpreting it. I don't know, how does Assista do something like that?
Yeah. Well, right now it doesn't.
Oh, okay.
In fact, I've just I've kind of avoided giving it access to large tables of data because I just know it's not going to work yet. So there's a lot of stuff that's on my roadmap for stuff to get to eventually. I have a lot of ideas, and I've seen a lot of stuff on that. So so maybe someday.
Is that also an area of research that you're kind of following closely with the large tabular type data to work with? I don't know if you have any thoughts on how far away we are from solving that kind of problem.
Well, the best I've seen has been code interpreter, and maybe O1 because it's the next generation, but that approach, as Shashank said, was to basically write some Python code to process the data. So it knows not to process it directly, but to use tools to process it, which makes a lot of sense, and it does a pretty amazing job at that. But it was also very limited. There was, I got onto about my third task or something with it, and it was unable to do it. So there's a lot of room for improvement there. I haven't seen anything that's been taken me by storm in terms of processing large tables with LLMs directly. It isn't, I don't know. maybe, computers are pre-AI and stuff are quite good at that. So maybe the answer is don't try to somehow subsume that in the AI part, how the AI use those tools. That might be the answer.
Yeah, that's actually probably a pretty smart way of approaching the problem. I mean, like, you're right. I mean, like, Excel exists, all these things exist that are like really good at like processing tabular data. Yeah. And we do have tool calling. So maybe like some sort of like agentic tool may be like the way of approaching kind of that problem.
I probably think business intelligence is where LLMs have a good use case to interpret this data, to help with analyses on large amounts of data in ways that human beings can understand.
Yeah. Well, I do want to work on, one of my next goals is to be able to say, at least a graph, actually, you say, interpret this graph for me and, add that in. So
no, that'd be pretty cool.
Yeah.
So yeah, I wanted to kind of switch this topic a little bit. We've talked a lot about like Analytica. We've talked about, some of like the history of like the Bay Area. But one thing that I know you've done some work on is around like AI risks and like specifically like existential risk. So I kind of wanted to get like your take on like maybe like mainly like what do you feel like the probability of like some sort of like existential doom is, like, like AI like killing all humans, and like do you think like there's any like merit to that? Like, is this something like that keeps you up at night, or like, do you think that's maybe just like overblown like movie thing? Like, I don't know if you have like thoughts on like what the actual like risks you see are of this like technology.
Yeah. So last year, a project that ended about a year ago and went for a year before that, just before a little bit before ChatGPT hype came in. I got pulled into a project called MTER, Modeling Transformational AI Risk. Because we specialize in modeling of unprecedented situations, they thought, they pulled me into the project to see if we could figure out how to model that exact question. So I worked on that for about a year, and actually coming up with a good model for that is pretty darn tough. It is tough. I became familiar with a lot of the stuff that's going on in the AI safety and existential risk field, and a lot of the let's say the arguments that field is making, and I mean the bottom line is, if an existential outcome occurred, it's so catastrophic that even if there's a low probability, you got to take it seriously. And the bottom line is that there seems to be merit to in my opinion, to the arguments. Basically, I had a colleague on the project who kept saying, I don't know what to think necessarily, but can you just tell me, can you just punch holes in these arguments? Where's the flaw in the argument? And it's like, if you really read a lot of these, they don't have very good, there's not really any flaws in the argument. They're well thought out. A really good book that I do recommend from quite a while ago is a book called Superintelligence by Nick Bostrom. And it's very well thought out. It's a little hard reading. It's kind of an academic-ish level reading in a lot of places. But he really thought this through, kind of in a technology-independent way. It's not like, here's how they're going to be implemented, but here's some things we can kind of figure out, we need to worry about, and here's why. So, but overall, I mean, myself, I'm a techno-optimist. I mean, I definitely am. I'm excited about this stuff. So, I think there's, the expected outcome and, very high probability outcome is that, in the long term, AI is going to improve humanity, in incredible ways. There's going to be a lot of disruption between here and there, but disruption is different from existential risk. But there is a small probability that we could end up, with an extinction event. So, right now is the time to be thinking about not arguing whether that's true or false necessarily, because the utility is so bad if it happens, but really focusing on what are the decisions that we have today to minimize that, because I think there are some. My personal opinion is that the things that we're likely to be able to control are almost all in the technology realm in terms of solving some of these alignment problems. The reality is today, we don't know how to control, let's say, a species that is, run circles around us in intelligence. We really have no idea how to. The gorilla's absolutely superior to us in every single physical way you can list, pretty much. But we have completely dominated it and subjugated it to this little area in Africa because of our intelligence, right? And, how are we to know that the species we create doesn't do the same thing to us? So I know there's some people, Hans Moravec, Rich Sutton, and some others that, view this as either inevitable and not necessarily that bad of a thing. These are our mind children, our descendants. So it's just a fact of life. They're not biological descendants, but they are our descendants. So it's just the way it is. If they're superior, they win out. But yeah. So I don't know. It's anyway.
Yeah. It's hard to say.
So based on the recent or maybe a few months ago coup that happened at OpenAI with Sam Altman's ousting and then subsequent rehiring and then more recently most of the executive board at OpenAI and some of the founders leaving and specifically Ilya Sutskever founding Safe Superintelligence. Which camp are you in? Are you pro progress, given all the progress that OpenAI has been making, releasing amazing models that you yourself are using today in your own product? Yeah. Or would you side with Ilya Sutskever and some of the others who are cautioning us to put the brakes on and think more deeply about some of the risks?
Yeah. And I guess I'm not completely convinced that that's quite Ilya's position, but there are people like Jeffrey Hinton and stuff who are definitely people I respect tremendously that are saying that. So I'm more in the pro-progress camp at this point. I mean, there's also a realism in here in that, there's no, you got to kind of put this in the context that there's no putting the genie back in the bottle. But I do think that the benefits are also really, just tantalizing. So I tend to be a little bit more definitely more on the pro-progress. But I kind of everything I do, though, I try to stay open, try to stay nuanced. So I don't necessarily, say that I'm like absolutely there. I kind of try to keep everything's a balance. You got to kind of have to take all these things seriously. So,
yeah, I think that's like a really good point, and I agree. I think that it's really hard to put the genie back in the bottle. I mean, like, let's say you stopped working on it, or like some other people like decide to stop working on it. So, well, it's not like you're gonna get everybody to stop working on it. I mean, like, progress is somewhat like decentralized. Like, maybe you could lock things down in America, but then like maybe China would be working on something, maybe someone in the Middle East, maybe like some guy in his bedroom like maybe decide to make like the next revolutionary breakthrough in AI. And I think that it's hard to stop it, which is both a little bit scary, right? Because like we don't know where that progress breakthrough will come from, but also incredibly exciting because we don't know where the progress breakthrough will come from. So yeah. I don't know. I think that like the way I kind of look at the problem is that like I sort of am aligned with you in saying that like I would like to see these things be built somewhat faster. And if we have quick building, then we can also have figure out like what the problems are and solve it more rapidly, right? So it's like, I mean, you can hypothetically go sit down, think about what you're going to do for days, weeks, years on end, and then make a decision. Or you could just like go make the decision, see how it turns out, and then if it doesn't turn out well, you could sort of iterate. And I think that as long as we can prevent these AI systems from having like too much power, I'm like, so I feel like as long as you don't like make like the robot with the gun and say like, hey, just like kill any terrorists, like you could probably be all right. Maybe it's a little extreme, but I feel like I like to see like the
Yeah, your description there actually was kind of a direct connection to what we talked about earlier, which is when is it worth building a model versus executing? And here you said I think like I'd like to just see us execute, not spend too much time deliberating and making a better decision, but run out and execute and iterate. And I mean, that's a good thing, because actually that's another thing to consider when you're thinking about that earlier question was. You do want to always set things up where you are in a position to iterate. But there's actually a cycle where the cycle isn't really just around iterate. It's around decide and iterate. So you're, at each moment you can decide whether it's worth spending more time on the decision. In this example, in this particular case, like I said, I spent a year working on modeling the risk. I think it's a worthwhile thing for some people to be working on. But I also definitely kind of felt from being on that it's a little bit too early to be too useful on that. And maybe that's, limits in my own creativity. Because, Nick Bostrom, I thought, actually did some amazing things in his book that maybe showed you can do a lot early on. But yeah, I do think, the more people are doing things, that are learning how we align these models and things, the better off we are.
I liked Zuckerberg's comment on this. He has a similar mentality as both of you. He mentioned that, yes, we should be mindful of some of these existential risks long term, but in the short term, I think some of the more practical risks are spreading misinformation, especially with the elections coming up, using LLMs to generate mass propaganda or campaigns that attack other people, create deepfakes, and so on. But setting politics aside a little bit, what do you think are some of the disruptions that we're going to face, especially with loss of jobs, or maybe like a slow transition into less hiring? And how can people adapt to this new world? What should they be learning? How can we prepare ourselves? Maybe for a younger audience entering college or high school, how do you prepare for this new world?
Yeah. So what disruptions are we going to see? One thing I want to say is for the short-term economic disruptions like job loss, I think we can look to history and look at other technological innovations and what they have done in terms of how they have transformed, job loss and things like that. Because at every stage of the way with previous technological innovations, we have seen, the opponents out there saying this is going to destroy jobs. It's going to
it's happened with the printing press too.
Printing press, automobile. Yeah, exactly. Everything, along the way, computer, all this stuff. And there seems to be a story that plays out every single time, which is there in fact are some segments that experience job loss. Particular jobs go away, and particular, towns where that was the only job there, suffer. And there's big disruption. But on the whole, the average well-being of society gets better. And there's a fundamental reason that happens every time is because these technological innovations improve productivity. And that means we can do more with less. And there's more value. So, you don't need horses anymore. Suddenly, you have the car, allows you to do things cheaper. You don't have to maintain stables anymore and all this stuff. And now you can use that money for other things. So, so we see that over and over again. These short-term disruptions that we're seeing in AI are in the same camp. They are the same thing. We're going to see localized disruptions, and we're going to see opportunities created elsewhere. And, we're probably feeling a little bit more because some of these are touching a little closer to us. So what does this mean, though, for people, especially young people, who are trying to figure out where to aim so they don't get disrupted. The first thing I'd say is I think the skilled trades are very safe for quite a while, so again, plumbers, carpenters, roofers, mechanics, and so on, machinists. So those areas, we've kind of undervalued them for a while, but I think we're going to see a shift again in society where those become some of the more valued professions, and a lot of the professions like marketing and copywriting and whatever. A lot of those types of professions are blue collar ones. Those are going to have some major disruptions and shifts. I think going into any of the technologies is actually going to be a very safe area to go into if you want to go into computer programming or things. I think you're actually safe if you can adopt the mentality that the fun of the job is not the particular technology you're working with today, but it is in fact the rapid change of technology and the ability to jump on new stuff and learn new stuff continuously. And if you have that mentality, then you're safe and you're in good shape going into these careers. So I don't advocate don't do it, as long as you have that mentality. And, I myself, I think, was lucky because from the age of 8, I got involved in the cutting edge technology, and it changed really fast my whole life. And I loved it. I loved the rate of change. I loved having the new stuff constantly. And I actually went into AI in 1987 because it just seemed so hard to do. It wasn't that it was a practical thing at the time. It was very fringe, but it just seemed like there's not a harder problem to solve. So, so I love that challenge and that change. Now if you have the mentality that, I'm a Python programmer, I'm going to learn Python, and then I got to stick with that the rest of my life. Yeah, Python's popular right now, but the odds of it being the center piece of skill for people in 10 years from now is very low. Not just because of AI, but just looking at history. What was the big thing 10 years ago wasn't Python. So it's that's just the way it is. I would not go into things that lead to kind of blue collar jobs that aren't sort of fundamentally technology and aren't fundamentally skilled trades. I think that would be a lot of those areas. I mean, that might include lawyers and stuff. I mean, doctors are always going to be safe, but I think AI is going to impinge on a lot of the academic parts of that. But a lot of office work type jobs and things like that, I think those are where you're probably risking it if you're aiming for those jobs.
So maybe like some like more clerical work that you might could see, like if you were doing like maybe data entry or something like that might be taken. Or I could even imagine like something where it's like really repeatable work. Like maybe if you were like, we're gonna move this box from here to there, or like we're gonna sort these things. I could imagine like AI with like some sort of like robotic hand could take that type of job. But I think you're spot on when it comes to like plumbing. I feel like that makes a lot of sense. And we were kind of mentioned before that like plumbing is hard. And I would love to see some sort of like AI like test to see like, hey, like who can be the first person to like automate a plumber? And like there should be some sort of like an X prize for like plumbing. I feel like that'd be pretty cool. Like some sort of like a $1 million prize automated plumber. That'd be pretty cool.
I will say though, across all fields, I mean, even if you are in a field, right now that's something like marketing or whatever, your future is not tied to that field you're in right now. It's tied to your ability to adapt. And, things don't change overnight. You realize that things do not change overnight. A lot of times when jobs get overtaken, it doesn't necessarily affect the people who are working in them that much. It the job drops off, but you'll find it's because people transition out of the job or retire and stuff. So truck drivers, for example, most truck drivers today are in their 50s. Young people aren't going into that profession because they know it's going to be automated. The truck drivers today, you're probably not going to get displaced, but, in a decade, most trucks will be automated. But the ones that are there are just going to retire. They're not going to get fired. They're not going to get replaced. It's just going to be kind of a transition, So that's the way a lot of jobs go sometimes. So,
yeah, makes sense. So one thing I wanted to ask you about is, you're a busy guy. You're the CTO of a company. You have a PhD. You have kids. You've been employed at like a company for 21 years as like an executive position, which is quite amazing that you've been able to do that. Like, kind of, how do you maintain like your work-life balance and still have time to do what it takes to run like the day-to-day operations of the company, like maintain your family life, and then also like play around with the new technologies and have time for like podcasts and whatnot? Like, how do you like structure your time and like your day?
Yeah. Well, one thing I'll say is my kids are all grown. I'm an empty nester now. So that frees up a lot of time. When I had 4 daughters, there wasn't much time at all for anything else. So there's, being, family, raising kids and stuff is an absolute commitment. And I committed the time to that. I made that the priority. But I've always been a workaholic. I mean, I've always just been so into the technology, and I think I value myself, my self-worth. I kind of value it through my productivity, so that's where I feel good about myself, is if I feel like I'm productive, and especially on technology and stuff. So I guess, that part kind of happens automatically, because of that enthusiasm. I did kind of take up a methodology in college that it didn't make sense to spend more than 8 hours a day focused, quote, on the job. And at the time, the job was for me studying. I got into engineering, of course, and I just fell in love with it. I loved college. I loved studying. Obviously, I did awesome. And that was, did very well.
You were the best at studying.
Yeah, apparently. But unlike a lot of my colleagues, I went home at 6 and went to bed. The only overnighter I pulled was actually, I think I was a graduate student already. It was a group project. We did the overnighter, I'm not sure if it was in a graduate course or an undergraduate course, but I remember we were implementing a 6802 as from the gate level processor. And that was a 2-day project or something, an overnighter in there. So,
was the overnighter effective?
Well, probably not, but it was kind of required because it involved multiple people, and the time slots would have been very hard to coordinate. To be able to really get everybody working on it at the same time for the same period of time. So, I did that. I did that through my career as well. I guess I'm a believer that what really determines your productivity is how focused you are, not how long you work. And I think if you work more than 8 hours on a job, you end up diluting your focus rather than the amount of stuff you get done. So for me, an hour of focus is worth 10 hours of mediocre time. And so that's, I think, a really key part. I was a really fast programmer. I don't think the distinction between programmers is that big anymore, but I do think back in the 80s and stuff, the 100-fold difference between the mediocre and the top programmer was a real thing, and I was definitely up there, so I was able to do a lot more than everybody else was with a small amount of time, so that helped. Another thing is I turned down a number of big opportunities to go into really, really high level positions. At one point, I was thinking, whether to become the CTO of AskJeeves, which was a 700-person company. And, after talking that over with my family and stuff, we decided, no, don't do it. Because, you got to leave time for the family. And so I've also been driven to stay close to the metal. I watched my dad, who was a super enthusiastic engineer out of college, and he was really good and stuff, and he moved very quickly into a management position. Was very soon was managing hundreds of people or something in, billion-dollar projects. And I saw his happiness with his job really deteriorate, with that. It just was not as fun for him. And so I kind of said, stay close to the metal. I don't know if I always, looking back, sometimes I kind of regret not doing, that, but it also allows you to keep more of a work-life balance if you don't jump for that. So that's kind of been one thing I've aimed for, don't jump for big management stuff, so if Lumina grew to where, I'd have to be managing 100 people, I would bring somebody else in to do that. I'd stay lower, So
I'm curious, just kind of like to dig in on that a little bit, is how do you manage like delegation? Because you said that you wanted to sort of focus on being close to the metal, and I know that a lot of the stuff that you ship from on Analytica and Lumina, that you work on that like yourself, right? Mm-hmm. But I also assume that there's only 24 hours a day. You have commitments outside of work. Like, how do you decide what is something that you want to work on versus like a delegate and have somebody else work on it? And I don't know, like, how do you decide what you're going to spend your focus time on?
Mm-hmm. I think that's an area I wish I could do better at myself, because a lot of that ends up being dictated because it ends up coming onto my plate and there's nobody else to do it. So that's not the ideal. Nobody else who has the skills to do it. So, which is not the ideal. My time at AskJeeves, I don't think I mentioned that, but I was with AskJeeves for a while. It was a startup in search engine in the 90s, and at that one I managed a bit larger group, and in one case a project that involved about 80 people by the time it was done, and I was leading the whole thing. And that involved people in all sorts of areas, because marketing came and said, I want you to build this. And so I had to integrate at that time, technical writers and marketing people and engineers and, the whole gamut and the QA and everything, and even some of the customers, and stuff. So, and I think mostly I was managing an engineering staff there. I was the director of engineering. Mostly, I guess what I thought was my job as a manager is to make the people working for me as successful as they can be. And so it wasn't so much how I delegate to them. I like people to pick their own tasks. I think I don't value ideas a lot. I think it's all in the execution. I think ideas are cheap. But if people have the ideas, if they think it was their own idea, even if everybody else has thought of it too, but if they think it was their own idea, let them run with it, because, let them prove that it works, and, that motivates people. And, I guess where I would step in is like, do I need to do something that person's going to have a hard time with? It's going to enable that person to be more successful, right? So that might be something that, their expertise isn't going to quite allow that, or is going to be too big of a learning curve or something. and just kind of look for those kind of opportunities, and then take on those things. I don't know if that makes sense.
It makes sense. Yeah. I think it kind of makes sense to be able to help enable people. And I like what you said about not like delegating, but having people kind of figure out like what's important to work on, or maybe you can even like help themselves figure out like what's important to work on. But I like that, not just like, oh, like you do this, you do this, you do this. It's like, and also I would imagine that's like probably takes a lot more mental bandwidth to figure out like exactly what everybody's doing, like, oh, this is what they're good at, like how they do that. It's like a lot, and it makes sense.
I'll mention one thing here, but other people might experience this too. I guess I'd be interested to hear from other people on this. We've entered an era of remote work, and in fact, my company has gone extreme because after the pandemic, me and my boss are the only two that ever come into the office regularly. So I'm in the office by myself all the time. Everybody else has found, they just continued working from home, which is kind of a lonely state. But I do find that, like what I mentioned, I find it's workable in person, and I have a hard time remote. I really don't know how to manage people remotely. I mean, I have not figured it out, because that same thing of being able to look at, where people are and, what's going to allow them to be successful and, all that stuff. It just seems like when you're remote, you almost have to delegate. You have to really very kind of micromanage the task specification. And so I don't know. That, to me, the whole remote work thing has just been really tough, and I have not really figured that one out. So I don't know. That's kind of an interesting topic area.
Yeah. Remote is interesting. I feel like when it comes to remote work, I think that it can work better, I think, when everybody is remote. I think that this whole hybrid thing is, in a certain sense, like kind of the worst of both worlds, because I think that like it makes sense. Like, hey, if everybody's in the office, you can kind of get that general like chit chat and figure out like what people are up to. Kind of figure out what people are blocked on. Like, if, like, for example, if you walk by somebody's desk and you see like, oh, like this is clearly not an efficient way of solving this, or like it seems like they're really stuck. Like, you can kind of like catch on that. But like when it's remote, like if somebody's like struggling for 2 days, you may not notice, right? And I think that at least I think like with remote work, something that I've seen is that like you have to kind of like almost force those like ad hoc conversations a little bit more. Like you have to like maybe have like I don't really like meetings because I feel like they can take away from the day. But I feel like in a certain sense, like when everybody's remote, it becomes like a little bit more important to like have like that regular update to say like, hey, like this is what I'm working on. Maybe this is what I'm stuck on. And then like even just like little time for like not do the work, but just like have a little bit of time for fun in the meetings too, that you could sort of figure out like maybe people's thoughts on things, stuff like that. So I don't know. That's just like something that like I've noticed, because like I mean, I haven't worked as long as you, but I've worked at a few different companies where it's been like fully in person, fully remote, and then hybrid. And I mean, I think hybrid can work if like we just come into the office on the same day. But yeah, I get what you're saying. Like if you're there just like alone in the office, it's like you might as well be remote. It's like it's basically remote at that point.
Yeah. For me, I like the transition though. I like to keep my work and home separate. So
right, yeah.
So I do that for that reason too.
For sure. Yeah. Makes sense. But yeah, I don't know. I think we've covered a lot of ground. I don't know, Shashank, if you had any other questions you want to ask about.
No, I think we went through a lot. What you're doing now, where you came from. Maybe one other thing I was curious about, and feel free to pass on this question, is the Lumina has been, I assume, a private company still for like 30 plus years, and you've been there for 20 plus years. Are there any plans to go public? And so the one analogy I have in my mind, and this may be incorrect, is like Palantir, which is doing similar things in terms of helping large organization, government entities make decisions about complex things. And they went public a while back, and I think they're doing pretty well. Does Lumina have any plans to go public? And are you hoping for that?
Yeah. Well, I have to say, I think going public is not anything in the near future for us. But there might be some structural changes coming up, in some ways, but I can't really go into that. So, yeah.
Of course.
So that's
Yeah.
fair.
Yeah.
And I guess one last thing before we kind of wrap it up, want to just kind of turn it to you. Do you have any questions for us? Or is there anything that maybe you want to mention? Anything at all that the floor is yours.
Oh, well, okay. Well, first of all, I thought today was really fun. So thanks for having me. I come to the generative AI meetup on Thursdays pretty regularly. I've been doing that the whole time, and I've gotten a lot out of it. And we have a small group at Panera, and the conversation goes all over the place. It's for listeners who are in Silicon Valley. Stop by and say hi, and let us know what you're doing. I noticed a bit of a difference at the beginning. The majority of people weren't even in AI and were coming to learn what the stuff was, just curious. A lot of the same people are still coming, but a lot of those actually have projects going on in the area. Almost everybody has something interesting they're working on. And, I've learned a lot of stuff from there that I would not have learned even from listening to podcasts or whatever, or reading papers. I read lots of papers. It's interesting. So, yeah. And I thank you two for organizing that too. It's non-trivial to keep that going like you have. As I said, actually, I don't know if I mentioned this, but, I talked about belonging to a homebrew computer club when I was a kid. It was a lot like this group. And, I got my first programming job in 8th grade
Wow.
because of a connection there. And then I got another job, my 4th job, not too long after that, that lasted for 6 years, and where I really found my mentor. I had a guy named Herb Pardula who had a startup company that I worked for 6 years. It's really where I learned a lot about programming. And
how old were you at this stage?
And that was also because of this group I belonged to. So, the first job actually was somebody who was in the group who hired me. And the other one was just like, hey, I know somebody, it was a connection that way. So, so anyway, there's a lot of stuff that happens, and at the time you don't really realize it, but you look back and you say, hey, that was important. So this group here is I'm sure it's like that for a lot of people who attend, So,
well, I appreciate that. Yeah. And it's I think it wasn't my idea to create the group. It was Shashank's idea. He noticed that it was just a real hassle to drive into the city, to go to San Francisco every day, or for all the different meetup groups, and we wanted something in the South Bay. And I think Shashank saw that there was kind of a desire to talk about this new cool generative AI stuff. And sorry, I'm speaking for you, Shashank.
I mean, it's a team effort. I think Mark is really the pillar who has stood here and built a community around him too. And he's the one who has a great voice and great charisma and the ability to socialize and bring people together and create an environment that is very accommodating and inviting. And I did think about some similar parallels with the homebrew club that you mentioned, and especially the idea that you all decided to pick a project and work on it together. Mm-hmm. That's something that some of the other group members have expressed too, and I think I feel like we should try to do that. Maybe put up a poll, have a request for ideas, and see which one people want to work on. Maybe one or multiple projects.
Yeah. It's similar to hackathons, but it could be at a kind of a more relaxed time scale.
Exactly,
and a little bit more of a figure it out together thing. So yeah.
Awesome.
Okay.
But anyways, yeah, so thanks so much for taking the time out of your busy day to come chat with us. I had so much fun, and I hope that the listeners got as much value out of this as I did, because this is fascinating to talk to you, and just a wealth of knowledge. And again, just thank you again. And By the way, just one more reminder, don't forget about the presentation that Lonnie's going to be making. So we'll be posting all of that details in the description. So yeah, I hope you all are able to go watch the full talk.
Yeah, check out the Risk Awareness Week on October 10th, and you get to sign up for 3 talks for free. So check it out. We'll post a link in the description.
Yeah, I hope you guys attend, and hope to see you there. And once again, thank you guys. This was great.
Yeah, this was a pleasure. Thank you so much.
Bye.